Huh. Okay. So come on. This happens sometimes. A stream sometimes crashes. The software will crash. And the next thing I need to do is recover. So this is a good segue for error recovery. How do you do that? Well, here I am. Ops crashed. I was able to take the stream down and bring it back up. What we're going to do is go back into our RSocket Interceptor stream and write some code. For now, I'm just going to show essentially what the basics are, what we're going to flush out eventually, and then build that. So we'll build a small sample client interceptor, and then we'll build it into our main project. And that main project will do some most of the nitty-gritty that I'm looking for out of this. So I don't know how to do this already, so I'm just learning this, but I did do some digging and then asking my friend ChatGPT on Slack and asking all sorts of things. How do I get an interceptor to work? And I kind of get the gist of it now. So I'm going to use this time to write that code. All right, so back to where we were before the stream crash. Yeah, so we have these RSocket strategies, and it essentially allows us to adapt to specifics of like encoding, decoding the actual reactive library that's backing our reactive streams, and things like changing the requester itself. How do you build the requester? So strategies gives us that. Or I'm sorry, not the requester, but the strategies builder. It looks like you have quite a few options with strategy. So if you're going down this path and you have some very specific things you need to change about how your RSocket works, such as metadata extraction, if you have specific metadata encodings, you want to go to RSocket strategies first, and then modify RSocket strategies to do the things that you're going to be expecting at the protocol level here. So let's move from RSocket strategies and let's move on. So we have this idea that RSocket, so we have this idea that RSocket requester has a builder, and RSocket requester is the thing that actually makes the call. So why is this important? Well, remember that RSocket strategies thing? RSocket strategies will get configured exactly first. Before the requester builder gets configured. The requester builder takes the strategies and it uses it to tell the requester about how to parse metadata, how do you encode, decode payloads, things, and which reactive adapter are we going to be using? Are we using Netty? Are we using Netflix? Are we using Java Flow? Things like that. So in this case, I'm going to use the provided requester builder because it already has these things baked in. So I don't need to tell it how to transform my objects. I don't need to tell it what kind of reactive framework I'm using. It's all just there. And it's very adaptable. So these things have lots of options, especially when you're dealing with an enterprise system and you have, somebody's using GCP or somebody's using gRPC somewhere and another person's using HTTP2, or you have WebSockets. These things are very adaptable. And the protocol and the underlying transport. So I'm taking the defaults and I'm just using connect TCP. This is already a deprecated call. And what's happening is I'm saying I'm going to connect to a server, and the server is whatever you pass into the port. The next thing is you have a requester. So when you take the requester, when you think about it, I want a requester per host in this case. So what I'll do is this particular method says, give me a username, give me a password, and I'll build you a requester that logs into a server that expects setup metadata. And setup metadata is a specific frame that happens when after you're connecting. And it says you're passing in a frame of metadata, and it has whatever type of authentication token or credentials that you need to tell the server on the other side who it is that's going to be talking here. So in this case, I'm using a username password metadata, which is very simple. There's a MIME type that's important, and that MIME type is just standard message RSocket authentication. It's just the x.rsocket.authentication v0. So that metadata tells us that there is that particular MIME type tells us that we have username password metadata, and that we can connect. And once we connect, we do things like, okay, well, when it's closed, then go ahead and close it. When you're done with it, close it. So let's move forward. So our request refactor is basic. It uses the request refactory builder to insert metadata into the connection frame or the setup frame and tell the server that who we are when we make that connection. Okay, so the next thing we need to know is, what is an interceptor? How do RSocket interceptors work? So RSocket interceptors work in a very straightforward way. We have an RSocket server. Because we have an RSocket server, we have the ability to take the connection, take the initial payload, and from that initial payload, we process various steps. And within that process are interceptors. So interceptors happen before your route method, your controller method gets hit. So in this case, we have what we want to do is we want to intercept the responses through our controller methods. So our controller methods are things like you saw earlier, this tree controller here. So you saw these message mappings. So each one of these shake for leaf, this rake for leaf, these are going to create responders in the background. Spring will create responders for each one of these, and those responders will be RSocket responders that correspond to an RSocket route, such as defined in the message mapping annotation. These methods are taken out and wrapped in an RSocket responder at the end of the day. So what we need to do is, before our responders get hit, we need to do some interception. We want to do some sort of logging. We want to see like what type of data is coming through. And so you can do that by using an RSocket server customizer. And that allows us to change various details of the RSocket server. In this case, we're going to customize our RSocket server to have an interceptor. And this particular interceptor, I'm calling it Global Interceptor, and I'm passing in the RSocket strategies bean. And Global Interceptor, well, you shouldn't look at what's happening in here. This is all proof of concept. But let's see. First thing is first. It's a component. It doesn't need to be a component. As you saw, I manually wired it in here. So if you want Spring to auto-scan it, use component. In this case, we're not going to use that. When it's componentized, you can also say order, and you can give it the order without implementing the ordered interface. So let's remove that, since we're not using auto-scanning to provide the global interceptor. Let's start at ordered. The ordered interface tells us in which arrangement are we going to hit this interceptor. Is it going to be first? Is it going to be somewhere in the middle? Or is it going to be last? In this case, highest precedence means it's going to get first. Lowest precedence means it'll be towards the end. So we don't know exactly where, but we do know that we can say, okay, well, I want this to be up front. I want it to come before my message mappings. So I'm going to make it highest precedence. I also want it to come before security happens. Security provides its own interceptor that does authentication on that particular metadata payload, the one that has the username and password. So I want this to become first before all of that happens. So I say highest precedence, I want it to get hit first, and I implement that method down here, which is get order, and just have it return, highest precedence. Next, secondly, is RSocket Interceptor itself, which is a function. This is a function that takes an RSocket, returns an RSocket. You take the RSocket, you mutate it, and then you return it. And however many interceptors there are, this can be, a chain of functions that happens somewhere. A function that returns multiple, an RSocket, and then another function that takes that and returns another one. How they're ordered is given by your ordered interface. Your ordered order, I guess. Is that get order? Yeah. So let's move on. So this interceptor is going to get called first. It's going to take a payload, and it's going to act only on request responses. I believe that's what I did here. However, RSocket interceptors can work outside of the scope of request and response. You can, as RSocket defines multiple request models, you have fire and forget, you have request stream, you have channel, which is like a multiplex streams, and then you have, of course, metadata push. And for us, we just want request response because this example that I wrote is only request response. So I said, okay, well, I'm going to create an anonymous object. I can just do this. I can say return that, and then I can get rid of this because I don't like having returns all the way at the very end of the class declaration or the method declaration. So okay, so I say, hey, return an anonymous object that is representative of the RSocket object. So RSocket is going to be the thing that I return, and here is the interception point. This interception point overrides the request response, and it takes the T, this is the RSocket that is passed in, and it says, okay, well, for a request and response, you're going to grab the payload, then you're going to emit a mono of the payload. In this case, what I would like to do is, don't need to worry about printing out the global payload. I created a context map. So what I will do is I'm going to insert some data into the reactive context. And so what I'll do is I want to essentially process the payload. You might be thinking, why do you have to process the payload? And the reason why is RSocket interceptors don't have access to your mapped controllers. Your mapped controllers contain all of the things that are arguments, the arity of the controller mapping, the thing that returns from the controller mapping. RSocket interceptors don't have access to any of that, so we deal in raw RSocket objects. In this case, it's the payload. And so what we do is we'll take the payload and we will, let's see, what are we going to do here? We're going to take the route out of the payload, and this is the manual way of grabbing the route. You should never do this on purpose. But what I wanted to do is prove that I can get the route out of the payload. And so that is definitely possible by parsing the MIME type of the RSocket composite metadata, and then extracting that particular metadata out. And what you'll get is a map of the different metadata key values. So in this case, I'm interested in the route. And so I'm able to say, okay, well, give me a metadata extractor, extract the metadata from the payload. This is the MIME type that I'm looking for, and the route is what sits under this MIME type, okay? So I have a map, and it has the route, and the route is and the actual route itself is the value. So, you could, for instance, make a global interceptor that takes the route and makes the decision based off of the route. You can say, okay, I don't want anybody accessing this particular route between the time of 5 p.m. and 8 p.m., right? You can do things like that. Here I'm printing out the decoders because I wanted to see what type of decoders are enumerated within this class. I can delete that because that doesn't really help me much. But in this case, the next thing I did was take the payload once again, and wrap it into a data buffer factory. So what does this mean? We have a byte buffer, and we're going to take that into a default data buffer. And the default data buffer is the, of course, byte buffer internally, but it has separate read and write positions. So I guess it allows us to do what? Rewind? Is there a rewind? No. This particular class is I guess it just has different. It's a very low level. You know, this is your raw payload. This is the raw bytes of your payload. And it doesn't require Netty in the class path, I guess. Huh. Inspired by Netty's byte buffer, introduced so that non-Netty runtimes do not require Netty in the class path. Okay, that makes a lot of sense. So if you're not using Netty, then how could you possibly get the payload? You might be doing something else. Okay, so this is Spring's way of wrapping the data buffer itself, the byte buffer itself. So what we'll do is we want to turn that into something that we can then operate on. And the RSocket strategies, which is a Spring concept, allows us to operate using these data buffers. And so what we did was we said, hey, okay, I'm going to grab a decoder, and that decoder should be able to resolve a map. So strategies knows about like JSON, you know, Jackson. It has different encoding strategies already. And it will be able to tell us if we can decode into a map. So what we did was we grabbed a decoder that can return a map, and then we decoded the data, the actual payload itself, the thing that we wrapped in a data buffer. We decoded it, and we said, here's a resolvable type, which is map, and here's the encoding that I'm expecting it to be in. This is the byte buffer. This is whatever's in that byte buffer. I'm expecting it to be in application CBOR. And what is application CBOR in the first place? That's a good question. It's like JSON. But it's more or less binary than JSON. So if that makes any sense, just consider it like BSON, but not BSON. CBOR is a more compact form of JSON. And finally, we have hints. I don't know how to use these hints. I just pass it an empty map. There's no reason for me to give it hints anyway. I don't have complex type systems here. So all that I want to do is return a map itself. And then I just, you know, I starred. I said, okay, I'm just going to return this and cast it as a map. Although I'm pretty sure at the end of the day, I might not need to do that either if I do this right. For now, I'm casting it because I understand that it will be returned as a map since I'm asking for a map. From there, I'm taking the map and I'm saying, let's iterate over however this object looks. So what we have is a map of objects that the payload represents. And sometimes we get objects that have the data type name. And in this case, we have a data type called tree species. And within that, we have the fields that represent the fields of tree species. Let's take a look at tree species really quickly to understand that. So I created a class, don't need that, called tree species. It contains two variables, or actually two properties, which is long and leaf, ID and leaf. But beyond that, I decorated tree species with a particular annotation. So let me give you an example really quickly. Typically, your JSON will be created like this. Right? So this will probably be your payload by default without any of this stuff here. However, after you insert the JSON type information, basically you want your JSON type info to give it the name, and you want to have the name as the property, and then that name property is a wrapper for the actual object itself. So this is how I'm configuring it. So after these two pieces of configuration, this is what our payload looks like. And this helps because I'm then able to go into the decoder as a map. I'm able to say, okay, well, I might have a number of objects in here, right? But typically I'll have one. But I want to know which object it is. So in this case, this is a POC, so I just said, okay, if you've got tree species as the key, then I know what the rest looks like. So I can expect an ID to be there. And that's pretty much what happens. So because of that, you saw that I have a context map. That context map gets added to our reactive pipeline, our reactive stream. We don't need that. So what is going to happen is we're going to call the original RSocket, and we're going to say original RSocket call request response on this payload here, right? And that's what the original RSocket will do. I can do my own processing as well. I can say, hey, mono.filter, right? But I'm not. I actually don't need to change anything. I just need to inspect the payload so that I can simply put a context object in. And in this case, I'm going to add whatever was added here, which is hopefully an ID. So downstream, I can then grab the ID and then do some logic against it. So I remember contexts propagate per subscription. And therefore it's not thread bound, it's subscription bound. And so subscriptions can jump threads, and subscriptions can, they can be in different places. They can be in different memory compartments, right? So what we want to do is just ensure that we can pass a signal downstream, and using the context is a good way of doing that. So that's all that this interceptor does. This interceptor takes the payload, it attempts to look at the route. It doesn't do anything, it just prints the route. But then it takes the actual payload itself, the data payload, and it says, okay, well, do we have a tree species? And if we do, push a context map with the ID of that tree species into the reactive context map. And there we go, and that's it. So that's a global interceptor. We also have payload interceptors. So these things happen after our server interceptors. These payload interceptors can get called sometime in the end of the call chain. And they are similar to the standard RSocket interceptors. However, what we need to do is not implement an RSocket server anymore. We don't need to wrap the RSocket server anymore. What we're going to do instead is use the payload interceptor chain, and the payload interceptor chain obviously gets called such as, this then next, that then next, and so on and so forth. So it's a almost functional type of a way of working with the filter. So this interceptor can then just say, throw an exception if you want. In this case, this interceptor, this payload interceptor, is going to print out, whatever came out of the security context, whatever happened in Spring Security gets printed out. We use reactive security context holder. And we get the authority, we get the authentication, and we say, okay, well, print out whoever's in here. This is POC, so I just need to do prints. And then the second thing is, remember that global interceptor that put an ID? Well, if it has an ID, print the ID out. Or just, say mono, then just. It doesn't have to go anywhere. We can print, you can say, hey, we have the ID. Okay. And finally, so we showed payload interceptors. Let's actually look into payload interceptors and find out where they come into use. So let's change the scope to project and libraries. And then we can go, okay, payload interceptor, find usages. Because what I eventually want to do is exactly find out, well, which one of these objects, which thing is going to use a payload interceptor. Is payload interceptor a security concept? It is a security concept. So let's take a look at here and say context payload interceptor chain, payload interceptor RSocket. So this might just be another RSocket interceptor that works discreetly with payloads. So it's an RSocket proxy. Okay. And what is an RSocket proxy? It's an okay, so it's an RSocket. So it's essentially an interceptor. It's an interceptor that works particularly with the payloads. And I guess it adds a more simple interface to accessing payloads. Although you got a question, at which stage does the payload interception happen? And I believe it's happening after the authentication phase. I want things to happen before the authentication phase in my production, which is why I opted for a global interceptor. Okay, so your payload interceptor is a standard RSocket interceptor at the end of the day. Excuse me. So socket acceptors are the things that happen when you establish the connection to the RSocket, because usually you will pass metadata about login when you establish the connection to your RSocket server. We won't be looking at that today. We're looking at steady state RSocket metadata transfer between metadata and downstream components. So I want my controllers to understand something about the request. Okay, so with that out of the way, let's go ahead and take a look, see at some tests. And we have a few tests here. I've been rewriting and writing and rewriting tests. And they come in, there's quite a few things that are happening here that I'm going to attempt to fix. For one thing, I broke my tests, and that's important because in order to know what I'm doing, I need to be able to fix the tests. So what I wanted to do here was write an interceptor that for every time a tree species with oak was passed in, would fail, would say, no, you can't do that. And currently this fails because I don't have that logic. So we can actually re-implement that logic here within the, we can do that here actually. So rather than just going, oh yeah, pass it into the context, I'm going to throw something. Actually, if I threw something here, then that wouldn't be a good idea. So what I should do here is, what should I do here? Should I do it in here or here? I don't want to add any more payload mangling things, so I'll add it to the global interceptor. Although, yeah, we'll do that in a global interceptor. So let's see. This catch does not need to be here. Actually, this catch only needs to be up here. Okay. And then how about let's see, I'm going to take the decoded data, and it's going to be a map. Let's see. Let's just get rid of the try-catch block entirely. So now we don't have a try-catch block if for instance, there was no data. Actually, this shouldn't error out because I'm asking if there is data. However, if it's not that particular set of data, then it will, I guess, throw. And maybe we don't want it to throw. How about if we did this? Let's see, when data type is decoded data type as map. Okay, we can do that. Well, let's see if it is an actual. So this is a really, really like decomposed version of doing it. So we do have a var called leaf. So we're going to look for the field called leaf and say, hey, is it oak? And if it is oak, go ahead and throw. We can't handle this data. All right, so let's see, is that going to work or not? Okay, right. So that passed the test, essentially stating that, yeah, it will do what I want it to do. If I were to test it again and say, hey, I'm going to give it woke, then it should fail. So I want this to fail. So as long as I can break my tests, I can fix my tests, then I have a reasonable understanding about what my code does. Okay, so that works. Okay, so as for the rest of the tests, let's see if we can fix that. Let's see if we can fix the other 90% that I did break, and for which reason I'm quite not certain as to what. Oh no, they're not all broken. Okay, good. So what happened here? What happened to rejected metadata setup? Oh yeah, you're printing all the stuff too. No handler for destination status dash slash 123. And that's probably because I changed it to dot. So we'll do that. We'll just say dot 123. And that should just unbreak all of our tests. If not, then something else happened. Yep, something else did happen. What happened? Rejected setup. Oh, expected error. Class failed. Huh. No setup metadata? Okay, so if you don't send setup metadata to status, it should say rejected setup error, but it didn't. This time it did something else. So what was the actual? Oh, the actual was fine. What's the deal here? Requester route status 123 reject. Oh, but okay. Probably it's because in tree server security, I have no way of saying pre-authorize. So it doesn't know that I need to be logged in. It just allows me to go ahead. So in this case, I should probably, no, actually, authentication principles should be there. Global interceptor is there. Let's look at this no metadata thing. Did we actually not send metadata? Yeah, we did actually send metadata. You know what happened was we sent metadata. RSocket requester, builder, connect TCP, block, okay. So one of these guys here sends metadata, one of these guys doesn't send metadata. I got the one here but didn't send metadata. Let's see what happens if I did this. Okay. Most likely, my RSocket server already knows that I'm connected, which is a problem. This should work because, well, I just sent you the wrong credentials. Right. Actual closed channel. Okay. So what we'll do is we won't shut, we'll run that test in isolation. I think that there is a dirty context, so there is a way to handle dirty contexts. I'm going to need to handle dirty contexts. How do you handle dirty contexts? I'm going to do a little bit of sleuthing. I just did some dirty context coding a second ago. Oh yes, okay, I remember. Gosh. Okay, let me go, ooh, hi. Okay, so what we want to do is we want to essentially refresh the context every time we test these things. Um, and I think it happened here. Let's let's see. I think I changed it here. Might have been here. Test container configuration. None of that. Repository. Okay, maybe it wasn't here. I'm gonna pretend like I know exactly where to look. And let's see. Do some sleuthing. I'm going to ask a friend. His name is ChatGPT. He basically, says, oh yeah, all that you need to do is download XYZ and place it in. So what we're going to do is, instead of our natural go to Slack or ask other people, we're going to say, okay, at Dirty's context. Okay, I wonder if I can add at Dirty's context for the entire class. That way, every test method, yeah. So let's see what happens here. Maybe every method now, these tests will take longer, that's for sure. And the reason why is that you got to start up the entire Spring application context each time. Okay. Let's try that again. No setup metadata. Hopefully that leaves the rest to work, because I know I have like, there we go. Nope. Okay, so you are not the same, mister. Should I even worry about this? I probably shouldn't worry about this yet. I know I want rejected setup, but I probably am not going to get rejected setup. This guy here doesn't even exist. That metadata should work, and let's try it again. Well, at least one of these tests should start working again. What I didn't do was, did I figure out if my status endpoint is working? Because it probably isn't. Incorrect password is rejected. So that should definitely be rejected setup. Nope, it's closed channel again. I wonder why I'm getting a closed channel. Oh, yeah. I know why. It's this guy here. Right. Right. Okay. Yes. So it's this guy here. My global interceptor is getting in the way. That's proving quite the problem. Because I anticipated this happening. I kind of knew that this would happen. So something in my global interceptor is throwing, and it is causing the connection to, well, it's causing the whole entire pipeline to stop. So given that, we're going to, I'm not going to need to fix this. This is just my POC. What do I really want to do? I really want to write a requester interceptor. This error is fine. I'm going to table this. I'm going to say, okay, fixed to fix the global interceptor. I don't want to think about that right now because it is being called, but it is throwing an error. Okay, so my global interceptor is throwing an error. In this case, do not worry about it. Move on to what you really want to do, which is demo chat. I guess the theory part of the stream is over. We can move on to the non-theory part of the stream. And what's going to happen next is it's going to get very loud in here. So I'm going to leave you guys. I'm going to create another stream in about a few hours. and I will stream again. And for now, thanks for visiting my channel. If you want to hear anything, if you have any specific things that you want to hear, send me a message, send me a text, send me whatever. You can always reach me at the following URL. Maybe, maybe not. Yeah, you can usually get me at Twitter here. You can get me at Mastodon over here. Oh, those guys are in the same place today. So shouldn't be nothing too hard. Let's just try to make our code tested. And let's have good confidence in our code. So writing these tests always help. Whether you have the energy or not to fix your production, that's a wholly different question. So those things take time, and we will do that in a couple of hours. See you later.